determine the number of number 12 American wire gauge conductors that can fit into a 4-inch square box with a depth of 1.5 inches and a 3/8-inch single gang ring, we need to understand the National Electrical Code, or NEC, guidelines for box fill. Box fill calculations are crucial to prevent overheating and ensure electrical safety. The NEC specifies the maximum number of conductors, devices, and fittings allowed in a box based on its volume. Firstly, we need to find the volume of the 4-inch square box. According to NEC Table 314.16, a 4-inch square box with a depth of 1.5 inches has a volume of 21 cubic inches. Secondly, we must account for the addition of the 3/8-inch single gang ring. The single gang ring effectively increases the usable volume of the box. For a 4-inch square box, a standard 3/8-inch raised single gang ring adds an additional volume allowance. However, for simplicity in this estimation, and since the exact volume added by the ring can vary slightly depending on the manufacturer, we will focus on the base box volume and address conductor fill based on that. In situations where precise calculations are critical, consulting the ring specifications or directly measuring the added volume is recommended. Thirdly, each number 12 American wire gauge conductor has a volume allowance. According to NEC Table 314.16, B1, each number 12 American wire gauge conductor requires 2.25 cubic inches of free space within the box. Fourthly, we calculate the number of conductors that can fit in the box. We divide the box volume by the volume allowance per conductor. So, we divide 21 cubic inches by 2.25 cubic inches per conductor. This gives us approximately 9.33. Now, this calculation is for conductor fill only. However, the NEC requires us to also account for other items that may be in the box, such as device yokes, internal cable clamps, support fittings, or equipment grounding conductors. Let's consider the impact of these additional items. Firstly, conductor fill allowance. As we calculated, the basic volume allows for approximately 9 number 12 American wire gauge conductors, if we only considered conductor fill. Secondly, equipment grounding conductors. All equipment grounding conductors that enter the box must be counted as a single conductor. Regardless of how many equipment grounding conductors are present, they are treated as one conductor for box fill calculations according to the NEC. This affects our available fill space. In our case, we will assume one equipment grounding conductor. This means we have to account for 2.25 cubic inches for this conductor, reducing the number of current carrying conductors that will fit in the box. Thirdly, device yokes or hickeys. If the box contains one or more devices, such as a switch or receptacle, each device yoke counts as 2 conductors based on the conductor size associated with the device's circuit. In our situation, we are asked to calculate the number 12 conductors that fit. So each device yoke counts as 2 number 12 conductors, or 4.5 cubic inches. Fourthly, internal cable clamps. If the box contains internal cable clamps, these count as 1 conductor, based on the largest conductor entering the box. In this scenario, we are using number 12 conductors, so that counts as 2.25 cubic inches. However, if the cable clamps are external, they don't count against the box fill. Fifthly, support fittings. Support fittings, such as brackets used to support the box, also count against the box fill. The NEC specifies how these fittings should be counted. Now let's consider a practical scenario. If we have one equipment grounding conductor, a single device yoke, and internal cable clamps, we can calculate the total volume occupied by these items. One equipment grounding conductor is 2.25 cubic inches. One device yoke is 2 number 12 conductors, which is 4.5 cubic inches. And one set of internal cable clamps is 2.25 cubic inches. The total volume used by these is 2.25 plus 4.5 plus 2.25, which equals 9 cubic inches. Now, we subtract this from the total box volume to find the remaining volume for the current carrying conductors. 21 cubic inches minus 9 cubic inches is 12 cubic inches. We then divide this remaining volume by the volume allowance per number 12 conductor, which is 2.25 cubic inches. So, 12 cubic inches divided by 2.25 cubic inches per conductor equals approximately 5.33. This means we can fit approximately 5 number 12 conductors in the box, considering the equipment grounding conductor, the device yoke, and the internal cable clamps. The NEC mandates that all conductors within a box, including spares or those passing through, must be counted when determining box fill. Each conductor must be included in the calculation. This requirement ensures that the box is not overfilled, which can lead to overheating and potentially hazardous conditions. However, there are some exceptions to the conductor count. Firstly, conductors that originate outside the box and terminate inside the box, without being spliced or terminated to a device within the box, are not counted. These are known as through conductors. Secondly, fixture wires that are smaller than number 14 American wire gauge, used for connecting luminaires or other equipment, are not required to be counted, if they are no more than 6 inches in length. Thirdly, jumper wires, used to connect devices within the box, are not counted if they are 6 inches or less in length and do not leave the box. Additionally, certain types of splices and terminations are permitted outside the box. These situations must comply with specific NEC requirements to ensure that the connections are safely enclosed and accessible. When planning an electrical installation, it is essential to accurately calculate the box fill to ensure compliance with the NEC. Overfilled boxes can lead to dangerous situations, including overheating, insulation damage, and potential fires. It is always better to use a larger box than to exceed the fill capacity of a smaller box. Furthermore, using the correct box size can simplify the wiring process and improve the overall safety and reliability of the electrical system. The NEC provides clear guidelines and tables to assist in calculating box fill. Consulting these resources and performing accurate calculations are crucial steps in ensuring a safe and compliant electrical installation. Remember that electrical work should only be performed by qualified and licensed electricians. This not only ensures compliance with local codes and regulations, but also protects against electrical hazards and ensures the safety of the installation. While we have simplified some aspects for illustrative purposes, always consult the latest edition of the NEC and local electrical codes for the most accurate and up-to-date information. Box fill calculations can be complex, and understanding all the factors involved is essential for ensuring electrical safety. The NEC is updated regularly to reflect changes in technology and safety standards, so it is important to stay informed and follow the latest requirements. By adhering to these guidelines and taking the time to perform accurate calculations, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations.